Hey there, Algebra 2 students. Today we're going to talk about the unit circle and special angles. So let's start off by getting a title on our page. Now this topic is going to overlap section 13.2 and 13.3. So you might want to rewatch the video before you start 13.3 or after you have finished 13.3. Okay, so a special angle is an angle that we frequently reference when solving and graphing trigonometric functions, and the special angles that we're going to be looking at are 30, 45, 60, and 90. So remember from section 13.2 that you can convert an angle in degrees by multiplying it by pi and dividing it by 180 degrees. So we're going to convert each angle into radians. So let's start with 30 degrees. So let's see, 30 degrees times pi divided by 180, and 30 goes into 180 6 times, so we would say pi over 6 radians. Okay, 45 degrees would be the same thing as, well, 45 goes into 184 times, so pi over 4 radians. 60 degrees would be 60 times pi over 180, so that would give you pi over 3 radians. And then lastly, 90 degrees, multiplying that by pi, 90 is going to go into 180 twice, so that is going to be pi over 2. So I would get these 4 special angles, 30, 45, 60, and 90. I would get them, their radian measures memorized, because it's going to make things go a lot smoother for you. So the unit circle is a special circle that we use in trigonometry, and the center of the circle is at the origin, and the radius of the circle is 1. Now, the equation for a circle is x squared plus y squared equals r squared. So if our radius is 1, then the equation for the unit circle is x squared plus y squared equals 1. And we're going to be using this to solve some problems in 13.3 and possibly 13.4. Okay, so let's first start off by looking at 90 degrees. So on my unit circle, I'm going to draw a unit circle here, and so we're centered at the origin here, and the radius is 1, okay? So if the radius is 1, that means that this point here on the x-axis would be the point 1, 0. Now, the point here on the positive y-axis on the unit circle would be the point 0, positive 1. And on the negative x-axis, we would have the point negative 1, 0. And then on the negative y-axis, we would have the point 0, negative 1. Okay? So if we know that 90 degrees is the same thing as pi over 2 radians, then we can label the radian measures for each point referencing 90 degrees on the unit circle. Okay, so of course when we are on the positive x-axis, we're here at 0 degrees. Actually, let me put that above here. 0 degrees, which would be 0 radians. Okay, and then 90 degrees is pi over 2 radians. Okay, now 180, 90 goes into there twice, so you would double 90 to get to 180. That means you double pi over 2 radians, which would be the same thing as pi radians. You can think about it like 1/2 times 2 is 1. Now, if we're on the negative y-axis, we are at 270 degrees, and 90 goes into 270 3 times. So if pi over 2 radians is 90 degrees, then 270 would be 3 times pi over 2 radians, or 3 pi over 2 radians. And then at 360 degrees, that's one full rotation of the circle, 90 goes into 364 times. So 4 times pi over 2, you can think about it like 4 times 1/2 is 2. So we would have 2 pi radians is the same thing as 360 degrees. Okay, now we're going to talk about the special angle 30 degrees. And for this, we're going to review the special right triangle 30, 60, 90 that you learned back in geometry. So I'm going to draw the 30, 60, 90 special right triangle here. Let's see that this is our 30-degree angle. And then, of course, this other angle would have to be 60 degrees because the angles in a triangle have to add up to 180 degrees. Okay? So the side opposite the 30-degree angle we say is x. The side opposite the 60-degree angle we say is x root 3. And then the hypotenuse is 2 times the value of x, or 2 times the side that's opposite the 30-degree angle. Okay, so let's think about, we have the unit circle here, okay, and then we're at 30 degrees. Now, what we're going to do is we're going to just pull this triangle out here. We know that our radius is 1, so the hypotenuse of this triangle is 1. So what we're going to do is we're going to solve this 30, 60, 90 triangle, assuming that the hypotenuse is 1, because that's the radius of the unit circle. Okay, so that means then that, let me just write, sometimes I like to write the theorem right in here. So the hypotenuse is going to be 2x, the side opposite the 30-degree angle is going to be x, and the side opposite the 60-degree angle is going to be x root 3. So if we know the hypotenuse is 1, that means that 2x is equal to 1. That would mean that x would equal 1/2. So the side opposite the 30-degree angle is 1/2. And then, of course, this other angle is 60 degrees, and the side opposite that angle would be x times root 3, or 1/2 times root 3. We are going to write it as root 3 over 2. Remember, we don't want any radicals in our denominator. All right, so now we're going to take this over to the unit circle and fill out our whole unit circle for our reference angles of 30 degrees. Okay, so you can see my triangle here in on my unit circle, and we just solved for the x value, which is root 3 over 2, and then the y value, which is 1/2. So that means that this coordinate right here on the unit circle is going to have an x value of root 3 over 2 and a y value of 1/2. Okay? Now, all 30-degree reference angles, is what we call them, are going to have very similar coordinates, but their signs will change based on which quadrant we're in. So let's look at quadrant 3 here. Now I'm at 30 degrees above the x-axis, but I'm in quadrant 2, so we would be looking at 150 degrees in standard position. Now, this triangle here is going to have this point on the unit circle. These triangles are going to be the same triangle, but since we're in quadrant 2, the x value is going to be negative and the y value is going to be positive. Now the same 30-degree angle in quadrant 3 now is going to have the same value. Now just assume this is a 30-degree angle here, right? So we're 30 degrees below the x-axis in quadrant 3, which would put us at 210. Okay, so Now, since we know we're in quadrant 3, then both x and y are going to be negative. And then if we look at the same 30-degree reference angle in quadrant 4, my y will be negative, but my x will be positive. So we're going to say root 3 over 2, negative 1/2. Okay? So let's see. This is a 30-degree angle. And we know that 30 degrees is the same thing as pi over 6 radians, okay? So now if we look at quadrant 2, we're 30 degrees above the x-axis, so that would mean that's 150 degrees, okay? So 150, how many times does 30 go into 150? Well, it goes in there 5 times. So that means I would take my radian measure, pi over 6, and multiply it by 5. So 5 pi over 6 would be the radian measure for 150 degrees. Now, when we look at quadrant 3, we're 30 degrees past the x-axis. So that means 30 degrees more than 180 degrees would put us at 210 degrees. And 30 goes into 210 7 times. So that would be the same thing as 7 pi over 6 radians. And then lastly, this 30-degree reference angle in quadrant 4, we're 30 degrees below the positive x-axis. So that means we're 30 degrees less than 360. So that would put us at 330 degrees. And 30 goes into 330 11 times. So that would be the same thing as 11 pi over 6. Okay? So those are what we call the 30-degree reference angles on the unit circle. So now we're going to talk about the special angle 45 degrees, and we're going to review the 45, 45, 90 special right triangle theorem from geometry. So for a 45, 45, 90 right triangle, we know that if there are two of the same angles, then the sides opposite them will be congruent. So it will be what we call an isosceles triangle. So these values, these legs, are going to be the same value. We're going to call them x. And then we can prove using the Pythagorean theorem that the hypotenuse then would be x root 2. Okay? So think about, here we have our unit circle, and we're at 45 degrees here, and our radius is equal to 1. Okay, so we're going to pull that triangle out, and we're going to solve it. So we're going to assume that the hypotenuse is 1, and we have two 45-degree angles. Okay, so let's see, I'm going to write the theorem inside of here. So the hypotenuse is x root 2, and then these sides are x. So we need to find x. So what we want to do is we want to set 1 equal to x root 2, and we want to solve. So you want to divide each side by root 2. So x is going to be 1 over root 2. And then we don't want radicals in the denominator. So we want to multiply the top and bottom by root 2. And that's going to give us root 2 over 2. So those are going to be the legs of our 45, 45, 90 right triangle, where the hypotenuse, or the radius of the unit circle, is 1. Okay? So let's put this on the unit circle and see what it looks like here. So we have our 45, 45, 90 right triangle drawn in here. We just showed that the x value is root 2 over 2, and the y value is root 2 over 2. So that means that this point on the unit circle is going to have the coordinates root 2 over 2, root 2 over 2. Okay, it has to be the same because it's an isosceles triangle, so two sides are congruent. Okay, now let's look at some of the 45-degree reference angles. Let's look at quadrant 2. Okay, so it's going to be the exact same triangle here. except for we're in quadrant 2, so our x value will be negative, but our y value will stay positive. In quadrant 3, okay, our x and y are negative. So it's going to be negative root 2 over 2, negative root 2 over 2. And then in quadrant number 4, x is positive, but y is negative. So root 2 over 2, negative root 2 over 2. Okay, now we're going to go through and we're going to fill in the angles with their radian measures. So we just converted at the beginning 45 degrees into radians, which was pi over 4 radians. So if you have that memorized, then you can go in and fill all the radian measures for each one of the 45-degree reference angles. So if we look at quadrant 2, we're 45 degrees above the negative x-axis, so we want 45 degrees less than 180. That would put us at 135 degrees. And 45 goes into 135 3 times. So I want to take my radian measure, pi over 4, and multiply it by 3. So that would be the same as 3 pi over 4 radians. In quadrant 3 here, we want 45 degrees more than 180. So that's going to put us at 225 degrees. And 45 goes into 225 5 times. So we want to take our radian measure, pi over 4, and we want to multiply it by 5. So 225 is the same thing as 5 pi over 4 radians. And then in quadrant 4, we want 45 degrees less than 360 degrees. So that's going to put us at 315 degrees in standard position. And 45 goes into 315 7 times. So we want to take our radian measure, pi over 4, and multiply it by 7. Okay? So last we want to look at the 60-degree angle. And for the 60-degree angle, you guys, we already solved the 30, 60, 90 triangle. So we're going to be using the same triangle, but we're just going to kind of turn it around a bit. So that 30, 60, 90 triangle, let's see here. I'm going to put my 60-degree angle here, 60 degrees, okay? So that means my 30-degree angle is going to be up top here. Now the side opposite that 30-degree angle is x. The side opposite the 60-degree angle is x root 3. And then the hypotenuse is going to be 2 times x. Okay? So think about, here's our unit circle. We have a 60-degree angle here. Okay? The radius is equal to 1. That's the hypotenuse of the triangle. So we're going to solve that triangle. And we already solved this, but we just need to kind of switch our values around a bit. So here's 60. We know our radius is 1. So I'm going to write the formula or the theorem in here. 2x is the hypotenuse. X root 3 is the side opposite the 60-degree angle. And then x is the side opposite the 30-degree angle. So if 2x is equal to 1, then x is equal to 1/2. So that would be the value of the base of that triangle. And then the height of that triangle is going to be 1/2 times root 3, or root 3 over 2. Okay, so let's take this to our unit circle here. We have our 60-degree angle. And we just solved for the base here, which is going to be our x value, and then the height, which is going to be root 3 over 2. So then the coordinates on this unit circle at 60 degrees in standard position, we are going to have an x value of 1/2 and a y value of root 3 over 2. Okay, so let's look at the other reference angles. Let's look in quadrant 2 here. Reference angle of 60 degrees. my x is going to be negative, my y is going to stay positive. In quadrant 3, my x and y are going to be negative. So negative 1/2, negative root 3 over 2. And then in quadrant 4, my x is positive, but my y is negative. Okay, so let's go through and fill out the angles here. In standard position at 60 degrees, we know that the corresponding radian measure for 60 degrees is pi over 3. Okay, if I look in quadrant 2, if my reference angle is 60 degrees, I want to go 60 degrees less than 180 would put me at 120 degrees. Okay, now 60 goes into 120 twice. So then 2 times pi over 3 would be the same radian measure. And in quadrant 3, we want to go 60 degrees below the x-axis, so that's going to be 60 more than 180, and that's going to put us at 240 degrees. And 60 goes into 240 4 times, so we want to multiply pi over 3 by 4, or 4 pi over 3 radians. And then lastly, here in quadrant 4, I want 60 degrees less than 360, so that's going to be 300 degrees, and 60 goes into 300 5 times, so we're going to multiply pi over 3 by 5. So 5 pi over 3 radians. Okay, so when you put it all together, you get every angle measure, our special angles, of course, 30, 45, 60, and 90, and then we can find the coordinates for each value on the unit circle. Okay, you're going to want to get this memorized, otherwise it's going to take you a very long time to solve trigonometric functions, because you're going to need to go through all of those steps just to find one point on the unit circle. Now keep in mind that a lot of these special angles, all the angles on the unit circle can be formed by a multiple of the special angles. Okay, so for instance, like if I looked at 240 degrees, well, I could use the reference angle of 30 degrees because I know 30 goes into 240 8 times. Or I could use the reference angle 60 because 60 goes into 240 4 times. So I can use these special angles to get other angles on the unit circle. Okay, I hope you found this video helpful. Stay tuned. Our next video is going to be section 13.3. I hope you have a great day, and thanks for watching.